Yes, no? Okay, there's an idea. I think a better way to do that is to try to stop those defects at the point where they occur. In other words, if we could prevent the defect from occurring in the first place, then we can stop the ping pong. Would you agree with that idea at least? So, one of the ideas around acceptance test-driven development, and one I want to explore for just a few moments, is that we actually build up a set of tests before we write the code. Okay? Now this idea is kind of shocking for somebody who's never heard this before. How can we write tests before the code is there? You have requirements. You have requirements, yes. You have specs, you're right. Yes. Well, the theory goes that if we could write a test before we write the code, you know, and if we had that automation coming into development, whenever developers thought that they were finished with the story, they could run those tests against their code and they would know right away that they forgot those two edge cases. And they could fix it. We could shorten that time loop or eliminate that loop altogether. If we could deliver a perfect set of a suite of tests to developers, we would never have a defect, right? So the truth is that this is not as hard to do as you might think. But one thing we need to do is separate out writing the test from running the test. Okay? So if we can write the test and run the test, see that it fails, have the developers build the code, write the code, and know that we have completed this story when the test runs green, when the tests all pass. The other nice thing about this is that those tests continue to build up a regression test. And this is one of the ideas that acceptance test-driven development brings to us. Only one, and we're going to explore a lot of others as well. But one of the general ideas is that we kind of specify, you mentioned requirements, we sort of specify up front what this story is supposed to do. And we collaborate together as a team, build up a set of tests that help us understand and know when we've delivered that story. Is this what you're doing? No? Yes? No? You guys know who this is? Uncle Bob. Any of you guys watch his videos that he's putting out lately? They're pretty hilarious. Well, Uncle Bob is one of these guys who has a way with words. In 1999, he was speaking at a conference. It was a testing conference. And he kind of banged his fist on the podium, jumped up and down a little bit, ran around in circles. If you know him, you know what I mean. And said, QA is dead. Oh yeah, that's what he said. What he was trying to say was that the way that we test software is stupid. It's ridiculous. Waiting until software is done and trying to verify the quality, we're way too late in the game. And it's no wonder that that our 2 months gets cut down to 2 weeks because we can't get the software development piece right either. So it's no slam against developers or the testers, but he is saying that the way that we test code just doesn't work. And then that idea, at that time, he came up with this idea that he presented to everybody. And he said, imagine if we could take the brain of a tester and put it in a bottle. See? If we could take the brain of a tester and put it in a bottle and carry it to the beginning of the project and pour it out and have that ability to find those defects kind of running along the table of development, how much better off would we be? In other words, what he was saying is that we need to get testers involved earlier in the process. Whenever we're trying to figure out what it is we need to build, and we need to pull the automation up to that level. Now, at the time he first proposed it, people thought, that guy's insane. He's crazy. There's no way that would ever work. But the truth is that he was pretty smart. He was also hanging out with Ward Cunningham, which is where he got the ideas. If we could do this, how would this reduce the number of defects that we find?
Substantially.
Substantially. Those of you who are doing this, have you seen that result?
Yes.
Well, I heard a yes. I heard somebody, but you guys are awful quiet. I think we need to have a 7th inning stretch here in a second. So, I can't see anything up there anyway. Okay. So, what does it mean when we use the word waste? Rework. If you study lean, lean says we should try to achieve this flow, right? Things should always flow forward at a decent rate. And if we see things starting to flow backwards, like some of those rivers down in Alabama right now, you know, that's not a good thing, right? That would be considered waste. Things moving backward in the value stream. Every time we have to send a piece of software back from test to development, that's waste, right? Finding defects is waste. Preventing defects is where we need to focus. But what about this whole rework due to unclear or changing requirements piece of this? Because that was the second thing we were going to talk about, right? How many of you get perfect requirements every time and they never ever change? Anybody? Well, I don't know that there is such a thing as perfect requirements, but I do want to talk about one thing. Right now, we tend to try to repeat the requirements that we get multiple times. And the way that we build up our test plans as testers is not dry. You guys know what I mean by not dry? What's dry mean? Don't repeat yourself. This was something that the XP guys came up. You know those XP hippie guys? They basically said if you find yourself doing the same thing more than once, you really need to try to find a way to only do it once. Because if you're doing it 2 or 3 or 4 times, you're probably not doing a good job. So let's explore this just a little bit. Whenever we're building software, we get this set of requirements, right? And then we go off and build code. And very often then the testers also build up a set of tests, maybe even test plans. You guys do that, right? What's interesting about this is that for every requirement that we get, we also usually build a test, right? So if we say that, you know, the system needs to do these 5 things, we typically build tests to make sure that it does those 5 things. That's what we do as testers, right? There's a problem with this. The problem is that so often testers have an evil mind. And they start to think about how things can go wrong. And they start to think about problems that can occur that was not obvious to anybody else. And all of a sudden, they start to build test cases for situations that nobody had thought about, things that were not in the original requirement spec. So we basically have the same thing being stated multiple times, captured by different people in different formats. What do you think the likelihood is that those things will ever stay in sync? They won't. They will not, guaranteed. So what happens is that that test runs after the fact, and we find a defect, and we send it back to development, and developers say, well, that wasn't in the requirements. And the test says, yeah, but it needs to do this, right? If it crashes like this, it's not, yeah, but it wasn't in the requirements, and all of a sudden we have this really unhealthy bickering and finger pointing going back and forth, and these walls get even higher between developers and testers, right? So what if we could do something like this? Well, first of all, wait a minute, I think I've got a transition here. Let me kick that off. Duplicate, yes, there it is. Okay. Was that cool? This is problematic, and this causes a lot of problems in the team. Also a lot of waste. You guys know who this is? Dan North. Yeah, hang on. Let me pop this over here. Dan North came up with this idea called behavior-driven development. If you haven't heard of that, but what he said was that we need to think differently about the way we describe our systems, and actually the way that we test them as well. And with the help of others, he came up with this idea, behavior-driven development. And if you go to Wikipedia, you'll see that there are some practices that are part of this idea. I'm going to list a couple of them here. Involve the stakeholders in the implementation process through outside-in software development. What does outside-in software development mean? Nobody knows. Yes, what's it mean? Yes, young man, what does that mean?
Product-oriented.
Product-oriented. Okay, product. Feature-oriented. You're very wise for your years, young man. He wrote the book on this. Use examples to describe the behavior of the system. What he means by examples is not tables, not descriptions, but real examples of how the system can be used. For example, if I'm building a little calculator, I don't say I should take two numbers and add them and I get the sum. That could be misinterpreted, right? It should say I add 4 and 6 together and I get 10. That's how we describe this system, using real examples. The other thing that he said, automate those examples to provide quick feedback and regression testing. So in other words, he was taking that idea that Bob had introduced about 4 years earlier and trying to make it a little bit more real. Let's try to find a way to describe our system in a way that everybody could read and understand, with a lot of examples of how it's used, and let's find a way to automate those. There's actually a few other practices, but I didn't throw them up here because they made my slide look cluttered. So we'll start there. This is what he said we should do. Okay, well that makes sense to me. They also came up with some interesting ideas around how should we define these stories, and I'm just going to quickly show you an example here. Do you guys use this whole as a such and such, I should do this in order to blah, blah, blah? You guys write your stories like this? Yeah? Yeah? Okay.